You know, in the massive world of the offshore industry, there are these heroes we never even see. They work 24/7 in some of the harshest environments on Earth, lifting just immense loads. And honestly, our safety often depends entirely on them. We're talking about wire ropes, and we're going to dive into this because their story, from creation all the way to retirement, is a real masterclass in engineering and safety.
Take a good look at this. I mean, it might just look like simple wear and tear, but in the offshore world, this level of corrosion represents a huge risk. Every frayed strand, every single spot of rust is a countdown. The failure of a rope like this isn't an inconvenience. It can be absolutely catastrophic.
So it's pretty clear these aren't just any old ropes. In that unforgiving marine environment, they are the critical link for everything from giant cranes to pipe laying equipment. They are truly the unsung heroes holding these massive operations together. Now, here's what's so fascinating. Making sure a rope doesn't fail isn't about luck. Not at all. It's all about a meticulously documented process. It's called an integrity management system. From the moment the idea for the rope is conceived to the day it's finally discarded, every single step is planned and recorded.
So let's start right at the beginning. The entire life and performance of a wire rope really hinges on getting these first steps absolutely perfect. This is where its future reliability is basically forged.
You definitely don't just pick a rope out of a catalog. Just look at this checklist. What's it for? A crane? Pipe laying? Is it going to be used subsea? Does it need to resist rotation? Does it need to be galvanized for corrosion protection? Every single one of these is a specific engineering decision, tailored to the exact job it's going to be doing for years. And the journey to actually get it into service is just as procedural. First, you've got that detailed selection we just talked about. Then it's carefully stored and preserved, and that could be for long periods. Finally, it's handled and installed with extreme care, way before it ever lifts a single pound. And this slide really shows you just how critical every little detail is. This quote, which comes directly from industry guidance, says it all. If you just wind the rope onto the drum the wrong way, maybe it's too loose or it's uneven, you can crush and distort it right from day one. You're basically creating weak points before its working life has even started. So once the rope is finally in service, the work is not over, not by a long shot. In fact, it's really just beginning. From this point on, its life is one of constant vigilance to maintain its integrity. And that vigilance really comes in two key forms. You've got your daily inspections. These are the quick visual once-overs by the crew. But then you have the thorough examination. This is a deep dive, a really detailed appraisal done by an independent expert at least once a year, and they're often using advanced tech. It's like two layers of a super important safety net. You know, every hero has its villains, and for a wire rope, the enemies are just relentless. They attack from the outside and, even more dangerously, from within. And recognizing these red flags, that's the core of an inspector's job. Here are two of the biggest threats right here. On the left, you're seeing failure from fatigue. That's the internal stress that builds up from being bent over pulleys and sheaves again and again and again. On the right, that's abrasion. That's external wear, basically friction from rubbing against surfaces. So one weakens it from the inside, the other grinds it down from the outside. But maybe the most sneaky enemy, especially in a marine environment, is corrosion. It doesn't just cause some surface rust. It literally eats away at the rope's metallic area, which reduces its strength. And it can happen silently, deep inside the rope where nobody can see it. And the list just keeps going. There's crushing from that bad spooling we mentioned earlier. There's something called bird caging, which is when the outer strands flare out from the core. And then you've got kinks, broken wires, a sudden reduction in the rope's diameter. An inspector is trained to spot all these little telltale signs of trouble. So, after all the inspections and all the monitoring for damage, we get to the most critical moment in a rope's life, the final verdict, the decision to retire it from service. And this isn't a guess, it's a science. A key tool in making that call is non-destructive examination, or NDE. Honestly, the best way to think about it is like an MRI for the rope. It uses these powerful magnets to see inside, detecting internal broken wires or hidden corrosion without ever having to cut the rope open. It's a total game changer for spotting hidden dangers. And here's what that technology actually looks like in the real world. That device is clamped right around the rope, scanning it as it passes through.
The data it kicks out gives inspectors this incredibly detailed picture of the rope's internal health, revealing flaws that a visual inspection could never, ever find. So, the crucial point here is that no single tool is perfect. A visual exam can't see inside, NDE needs a really skilled operator to interpret the results, and destructive testing, which is the only way to confirm the rope's actual remaining strength, well, it destroys the sample you test. The real power comes from using all these tools together to build a complete picture. Okay, now I want you to just remember this number, 5%. It seems incredibly small, doesn't it? But in the world of these high-performance, rotation-resistant ropes, a reduction in diameter of just 5% can be an immediate reason to discard it, even if there isn't a single visible broken wire on the outside. It just goes to show you how precise the safety margins are and how a tiny, tiny change can signal a major internal problem. And believe it or not, the story doesn't even end when the rope is discarded. After a rope is retired, it's often taken apart and studied. This post-retirement examination provides this invaluable data on how it wore down, and all that information gets fed right back into the system to make the next generation of ropes even safer. So you see, a wire rope isn't just a piece of equipment. It's a managed asset with a whole life story that's rooted in decades of engineering, which kind of leaves you with the final thought. If this is the level of detail that goes into just one component, what other invisible, highly engineered safety systems are quietly at work all around us, keeping our world running every single day?